Welcome back to all. So in this lecture, that is lecture number 22 of quantum mechanics, I will talk about a very interesting thought experiment that is called Schrodinger's cat. So why there is the need of to do these types of thought experiment? To understand this, at first we have to understand a theory that is called wave function collapse for superposition of state. So after that we will understand that why we need to do these types of thought experiment that has been done by Schrodinger, that is called Schrodinger's famous cat experiment. So in my older lecture, where according to the superposition principle, any function, that is f, ket vector f, can be expressed as a linear combination of the eigenfunction of Hamiltonian operator. So this is according to the superposition principle. So you can see that this function has been expressed as a linear combination of ket vector n, and this ket vector n is basically an eigenfunction of Hamiltonian operator, and Cn is the corresponding coefficients. So we can write this wave function as a linear combination. Now there is some normalization condition that has to be maintained to make this wave function a normalized wave function. So the normalized condition is that summation of square of the all coefficients has to be equal to 1. So this is the normalization condition for the wave function to be normalized. So here Cn square is basically probability, but probability of measuring the eigenfunction or eigenvalue En. So this Cn square is basically the probability of measuring the eigenvalue En. Okay, so let's take some simple example where this is the wave function which is expressed as a linear combination of two eigenfunction of this Hamiltonian operator, and this eigenfunction is psi1 and psi2, and root 2 by 3 and root 1 by 3 are the corresponding coefficients of these two function. And you can see that if we take the square of 2 by 3 and square of 1 by 3 and sum of them, the sum of these two will be equal to 1. So we can say that this wave function is basically a normalized wave function, as this normalization condition is satisfied. Now this root 2 by 3 and root 1 by 3, these coefficients basically tell us about the probability of measuring the corresponding eigenvalue, which is the energy E1 or E2. Okay, so this the probability of measuring this eigenvalue is dependent upon the square of this coefficients. So as you know that according to the postulate 3, if you do not know about this postulate 3, you can go back to my older lecture where I have discussed about the 5 postulates of quantum mechanics. So one of the postulate is that whenever we measure any observable of a system, we will not obtain the expectation value, we will obtain the eigenvalues only. So if you measure any system, you will only obtain either E1 or E2, you will not get the average value of the energy, you will only get these eigenvalues E1 or E2. So you are measuring the energy of a system, or a state, that is called psi, which is basically a linear combination of the two eigenstate that has been expressed in my previous slide. I have shown you the equation of this function psi, which is basically a linear combination of psi1 and psi2, and psi1 and psi2 are eigenfunction of the Hamiltonian operator. So if you want to measure the energy of this system, you will only obtain either E1 or E2, and whether you will get E1 or E2 will depend upon the probability. The probability depend upon this coefficient. So there is 2/3 probability that you obtain E1, and there is 1/3 probability that you will obtain E2. So suppose that after the first measurement we have obtained the eigenvalue E1. Okay, so if we measure the energy of that system second time, in that case the interesting thing occurred. What is that interesting thing? in that case the probability of measuring this E1 will not be 2/3. While you measure the second time, the probability of measuring E1 will be 100%. So you can see similarly, if after the first measurement, if you measure the energy of the system is E2, and again if you measure the system, you will get the probability, there is 100% probability that you will obtain E2. So according to this collapse of the superposition of state, it is said that if we measure the system again, then what happened, that those probability, that is 2/3 and 1/3, will not be remain same, or will not be remain the probability anymore, and the this state, that is the superposition of the two eigen state, will be collapsed into one of these eigen state. Either it will collapse into psi1 or it will collapse into psi2 after the first measurement. So after the first measurement, if we do the second measurement, you will only get the eigenvalues either E1 or E2, and each time you will obtain the same value. If we measure for first time, and if you obtain the value E1, then if you measure how many times if you measure, you will only get E1. Similarly, at the first measurement, if you get E1, E2, then how many times if you measure 100 times, each time you will obtain only E2, because this state after the first measurement will collapse into either psi1 or psi2. So that's why at each time you will get only same value. So this phenomenon is called the wave function collapse. Now this is this is a very interesting phenomenon, and this phenomenon is basically called a Copenhagen interpretation. So according to the Copenhagen interpretation, the initial wave function or state of a system will collapse into one of the eigen state, that is psi1 or psi2, after the measurement. So there are so many debate about this Copenhagen interpretation, because the behavior or this interpretation is very strange, because the wave function, that is initially superposition of this two wave function, after the first measurement will be collapsed totally. It will not remain the same, it will only become either psi1 or either psi2. So these types of behavior or these types of collapse of this wave function is called Copenhagen interpretation, which is very strange theory. So there are so many debates about this theory, and scientist Schrodinger, who has derived this Schrodinger's equation, has some argument, and he shows that these types of Copenhagen interpretation has some problem. So this problem has been shown by some thought experiment, and this thought experiment is known as Schrodinger's cat experiment. So what is Schrodinger's cat experiment? So it is basically a thought experiment. What is thought experiment? Thought experiment is an experiment which is not performed, but it is an imaginary experiment. So it is according to the imagination of the scientist. So these types of experiment is called the thought experiment. So basically there is some problem lies in the Copenhagen interpretation. So what is this problem? To show this problem, Schrodinger has introduced this thought experiment in the year of 1935, that is called Schrodinger's cat. So according to the experiment, suppose that there is some particle, or you can say some radioactive particle, which is in a binary state. So it has two states. The first state is that it can decay, and the second state is that it will not decay, and there is 50% probability that this particle will decay, and there is 50% probability that it will not decay. So that's why this particle is called a binary state. So decaying state is one eigenfunction, and not decaying state is another eigenfunction, and the state of this particle is basically superposition of these two states. So that's why we call this particle a binary state. So you can see that this is the arrangement of this thought experiment. So what is this arrangement? So this is the quantum mechanical particle. As you can see, it is it is enclosed in a sealed vessel, so no one can enter into this vessel, or no one can goes out of this vessel or this box. Okay, so this is the quantum mechanical particle, which is attached with some vial, and in this vial some kind of poison is there. So the arrangement is done in such a way that if the particle decay, then this bottle will open up and the poison will release and the cat will die. On the other hand, if this particle do not decay, then the bottle will not open and the cat will be alive. So you can see that the quantum state of the particle, that whether it will decay or not, is linked with the life or death of that cat. So if the quantum state is decaying quantum state, then the cat will die, and it is not decaying quantum state, the cat will be alive. So it is his life, this cat's life or death is related to the state of this particle. So initially this state is basically overlap or the linear combination of these two state, that is these coefficients are 1 root over of 1 by 2, and this state, that is y, is called the alive state, that is not decayed state, and this state is called dead state or decayed state. So in that state the cat will be dead, and if the particle is in this state, not decayed state, it will be alive. Okay, so if according to the Copenhagen principle, before opening the box, there is 50% chance that that the particle will not decay, the cat will be alive, and there is 50% chance that the particle will decay, so the cat will be dead. So before opening the box, so opening the box is basically carrying out the experiment, that is equivalent to carrying out the experiment. So before opening that box, there is 50% probability of the cat alive and 50% the cat will be dead. Now suppose that we open the box and we have seen that the cat is alive. Okay, so after that, so many times if we again close this box and again open this, what we will see? In that case there is 100% chance that the cat will be alive only. So how many times after opening the box, if we see that the cat is alive, after that how many times if we open this box, we will see the same result, that the cat will be alive. So on the contrary, after opening the box, if we see that the cat is dead, then again we close the box and again we open, we will see the same results. So if we repeat this thing so many times, we can see that the cat will be dead only. So you can see that according to this theory, the state of the particle is initially binary state, but after opening the box or after carrying out this experiment, the state of this particle collapsed into one of these state, either it is decaying state or non-decaying state. So this is the thought experiment that has been performed by the Schrodinger. But there is some problem. So what is the problem? The problem is that before the problem lying before the opening of the box. So according to the theory, before opening of the box, there is 50% chance that the particle will decay and 50% chance the particle will not decay, because the state of this particle is a binary. It is over linear combination of these two states. So according to it, before opening the box, the cat is equally dead or equally alive. So this thing is very ridiculous thing. So before the box is opened, it is not so practically what happened, that if the cat is alive, it will be alive before the box is opened. If the cat is dead, it should be dead before the opening of the box. But according to this theory, that is Copenhagen interpretation, the cat will be dead as well as alive before opening the box, which is basically practically not possible. So that is the that is a ridiculous thing, that before opening the box it should be either dead or alive, but according to the theory that is given by Copenhagen, before opening the box the cat is equally dead or alive. So this thing contradicts with the Schrodinger's experiment, thought experiment. So by doing this thought experiment, Schrodinger has shown that there is some lack or there is some problem in the theory that has been given by Copenhagen, that the state of this wave function, which is basically a linear combination of two wave function, will collapse into one of this eigen function. So this theory has some problem, because this theory cannot fully explain this Schrodinger's cat experiment, and if we apply this theory into this Schrodinger's cat experiment, we will reach into some conclusion that is the cat is equally dead or alive, which is very ridiculous. So that is why this experiment is very famous. It is known as Schrodinger's cat experiment. So if you like this lecture, please comment down below, and if you have any questions regarding this lecture, you can ask me through the comment section. And please do subscribe to my channel that is called Chem Biases. In this channel I will upload regular lecture on different aspects of chemistry. So right now I will upload most of the lecture on quantum mechanics, but eventually I will upload all other things like inorganic chemistry, organic chemistry, all those things I will upload. So if you like this, please subscribe, and thank you for watching this video. Bye.